Question 54. We have piecewise defined function. If x is less than -2, then f of x is this. If x is greater than -2, then function f is this. The question is to find limit as x approaches -2 f of x, if it exists, or explain why it does not exist. Okay, so let's say this is x-axis. This is the x-axis, and let's say here's -2, right? If x is less than -2, we have this function, right? So we're going to have to find the left-hand limit of this function, right? As x approaches -2, right? So limit as x approaches -2 from left-hand side, we have a -4x minus 8 over x plus 2. So that is equal to limit as x approaches -2 from left-hand side. If we factor this, that's -4 times x plus 2, and we have x plus 2 here. So we can cancel this factor right here. So that's going to be equal to just a -4, right? So the left-hand limit of this function f of x is equal to -4. And let's find the right-hand limit. If x approaches -2 from the right-hand side, we have to find the limit from this function, right? Because f is defined as this if x is greater than -2. So limit as x approaches -2 from right-hand side, we have x squared minus 4 over 2x squared plus 5x plus 2. So let's simplify this. X squared minus 4, that is equal to x minus 2, x plus 2, and over 2x squared plus 5x plus 2. That's, let's say we have a 2x here, x here, and we must have 2 here, plus 1 here, right? So that 2x plus 2, that's plus 4x. 1 plus x, that's plus 1x. If we add those two terms, we'll have a 5x, right? So x plus 2 will be cancelled out, right? So that is equal to limit as x approaches -2 from right-hand side, x minus 2 over 2x plus 1. Now substitute -2 for x. So -2 here, -2 here. That's going to be equal to -4 over, isn't it -3? -3. So that is equal to 4 over 3, right? Which is not equal to this value right here, the left-hand limit. So since left-hand limit and right-hand limit are not equal to each other, we can conclude that this limit doesn't exist. Limit as x approaches -2, f of x does not exist because limit as x approaches -2 from left-hand side is not equal to the limit as x approaches -2 from right-hand side, right? Question 59. The line x is equal to is a vertical asymptote to the graph of g. If g is greater than 0 for all x except x is equal to, which of the following must be true? So let's draw the graph of g roughly. Here, what we know is we have a vertical asymptote at x equal to, and g is positive for all x, right? Except x is equal to. So we could have this type of graph. You know, g approaches positive infinity as x approaches -2 from left-hand side, and g also approaches positive infinity as x approaches 2 from right-hand side, right? we cannot draw like this, right? Because it says g is positive for all x. Okay, so we must have g above the x-axis. Does that make sense? Okay, answer choice A. G of 2 exists. No, that's not true, right? Because we have a vertical asymptote at x equal 2. That means g of 2 is not defined. So that's not true. The answer choice B. As x approaches infinity, g of x is equal to. Well, x approaches infinity has to do with the horizontal asymptote of the function, right? Is the horizontal asymptote of the graph of g is always equal to 2? No, right? We could have, let's say for example, let's say here is 1. So we could have a horizontal at y equal 1, right? Like this. Does that make sense? So this is not always equal to 2. Okay, now answer choice C. G has exactly one horizontal asymptote. We could have one horizontal asymptote, or we could have no horizontal asymptote, or we could have more than one horizontal asymptote, which means 2 horizontal asymptotes. We could have this graph, right? Let's say this approaches 0 as x approaches negative infinity. Then if we have this type of graph, horizontal asymptote is y is equal to 1, right? And y is equal to 0, right? We could have 2 horizontal asymptotes. So that's not always true, right? Okay, answer choice D. As x approaches 2 from left-hand side, 2 from right-hand side, right? G of x is equal to infinity. That is true, right? We have a vertical asymptote here. Then graph has to, follow this vertical asymptote. Since g is positive for all x, this graph goes up like this from left-hand side. Also from right-hand side, the graph has to go like this, right? So as x approaches 2 from left-hand side and right-hand side, g of x approaches positive infinity. That's true, right? So the answer has to be D. Question 64. Which of the following statements about the graph of g is true? Answer choice A says g has horizontal asymptote at y equal 1. B, horizontal asymptote at y is equal to negative 1. C, g has a vertical asymptote at x equal 1. D, vertical asymptote at x equal negative 1. So basically, we have to find the horizontal and vertical asymptote of the graph of g, right? Remember, horizontal asymptote has to do with infinite limit, right? When x approaches positive, either positive or negative infinity, right? So let's look for horizontal asymptote first. Let's say x approaches either positive or negative infinity. Then what does this expression right here approach? X over x squared minus 1. Okay, that is equal to, well, that actually approaches to 0, right? When we look at the degree of the denominator, that's 2. And degree of the numerator, that's 1. When the degree of denominator is greater than the degree of numerator, it always approaches 0 when x approaches either positive or negative infinity, right? Then what about g? G is cosine of x squared minus 1, right? So when x approaches positive infinity, this expression approaches 0. This means when this expression approaches 0, what about cosine? Cosine approaches to 1, right? Remember, cosine 0 is equal to 1. Does that make sense? So when this expression approaches 0, right? When this expression approaches 0, cosine 0 that approaches to 1, right? I mean cosine x over x squared minus 1 approaches 1. So horizontal asymptote is y is equal to 1. So the answer is A. Alright? Now let's talk about vertical asymptotes. The vertical asymptotes occur when the denominator of a rational expression is equal to 0, right? But here the function g is not a rational function. This is cosine function, cosine of this angle, right? So no matter what angle value comes here, the function g is always between -1 and 1, right? Remember, cosine graph looks like this, starting from 1, goes to 0, goes to -1, 0, 1, right? The value of cosine is always between -1 and 1, right? So, therefore, the g function, which is a cosine function, doesn't have any vertical asymptotes. Okay? So the answer for question 64 is A. Question 69. If the function f is defined as above, for what value of a is function f continuous at x equal to -1/2? Okay, there are three conditions for f to be continuous at x equal to -1/2. That's number 1, the function f at 1/2 has to exist, right? So this value has to exist. Number 2, limit as x approaches -1/2, f of x has to exist. Okay. Number 3 is what? This function value and limit value, they have to be equal to each other, right? So number 3 condition is f of -1/2 has to be equal to limit as x approaches -1/2 f of x. Okay, here when x is equal to -1/2, the function value is equal to a, right? So we have f of -1/2 is equal to a. Now we have to find the limit of f of x when x approaches -1/2, right? So limit as x approaches -1/2, when x is not equal to 1/2, f of x is this expression right here, right? So we're gonna write that function of f of x, 6x squared plus x minus 1 over 4x squared minus 1. So this one is equal to limit as x approaches -1/2. Here, let's factor this. That's 3x, 2x. We have a plus 1, so plus 1 here, minus 1 here, right? So plus 3x minus 2x gives us plus x. So denominator, that's going to be 2x minus 1, 2x plus 1. So these two factors cancels out, right? So what is the limit value? Substitute -1/2 for x. Here, -1/2. So 3 times the -1/2, that's a -3/2 minus 1 over denominator, we have a -1 minus 1, right? -1 minus 1. So that is equal to -5/2 over -2, negative over negative, positive. So this is going to be 5/4, right? So this function is continuous when this function value is equal to this limit value, right? This limit value is 5/4. So when a is equal to 5/4, then the function f is continuous at x equal to negative 1/2. Question 74. If the function f is defined as above, which of the following is true? So let's look at the answer choices. Answer choice A. We have f is continuous at x equal 3. The function f is continuous if the function value is equal to limit value, right, at x equal 3. So when x is equal to 3, the function value is negative 9/8. So f of 3 is equal to negative 9/8. And we want to check if the limit value, the limit as x approaches 3, f of x, this expression right here, is equal to the function value f of 3. Okay, so we have 2x squared minus 3x minus 9 over x squared plus 2x minus 15, right? So let's simplify this. Factor numerator and denominator. If we factor numerator, that's going to be 2x, x. We have negative 9, so minus 3 here, plus 3 here, right? So 2x times minus 3, that's minus 6x. 3 times x plus 3x. So sum of those two terms is equal to negative 3x. And 3 times negative 3, negative 9, right? Here, denominator. Denominator is easy. X squared plus 2x minus 15, that's x plus 5, x minus 3, right? So cancel x minus 3 from numerator and denominator. And the limit value is equal to, then substitute 3 for x, right? So that's going to be 6 plus 3, that's 9. 3 plus 5, that's 8. Well, the limit value is actually positive 9/8, right? Which is not equal to the function value, f of 3. So this is not true. The answer choice A is not true. F is not continuous at x equal 3. So far so good? Okay. Answer choice B. Limit as x approaches infinity. F of x is equal to 1/2. And let's see if this is true. Infinite limit has to do with the horizontal asymptote of the function, right? So this is a rational function, right? The degree of the denominator is 2. The degree of the numerator is also 2, right? I mean, highest degree. And if the degrees are same, then horizontal asymptote is always equal to leading coefficient of numerator over leading coefficient of denominator, which is equal to 2/1, right? Not 1/2. So B is not true. Does that make sense? Okay, part C, answer choice C. Limit as x approaches negative 5 from left hand side. F of x is equal to infinity. Okay, let's see if this is true. F function is right here, and we simplified it. That is equal to 2x plus 3 over x plus 5, right? So let me rewrite that. F of x is equal to 2x plus 3 over x plus 5. And denominator is equal to 0 when x is equal to negative 5. So we have vertical asymptote at x equal to negative 5, right? Vertical asymptote occurs when the denominator is equal to 0. So let's draw the graph. Here's y-axis, x-axis. Here we have negative 5, right? Negative 5. So as x approaches negative 5 from left-hand side, so as x approaches negative 5 from, that's from right-hand side, I'm sorry. Okay, from left-hand side, from here to here. Okay, what about the function f of x? Here, I'm going to substitute, let's say, value negative 5.1. Okay, so substitute negative 5.1. Negative 5.1. Okay, we don't have to find exact value of f of x when x is equal to negative 5.1. All we have to know is if this is positive or negative. Okay, so if x is negative 5.1, is this positive or negative? Numerator first. Numerator is negative, right? 2 times in negative 5, that's about negative 10. Negative 10 plus 7, that's negative. So this is negative here. What about denominator? Negative 5.1 plus 5, that's negative, right? So negative over negative is equal to positive, right? So as x approaches negative 5 from left-hand side, the function approaches to positive infinity, like that, right? So C is true. C is the answer. Okay. The answer choice D. F has a vertical asymptote at x equals 3. Well, we canceled it out, right? The factor x minus 3 is canceled out. If the factor is canceled out, we will have whole, right? Whole at x equals 3, not vertical asymptote, right? Question 77. The continuous function h is given above. Given h over 4 is equal to 0, find the value of a, b, and c. Okay, the function h is continuous. That means it is continuous at x equals 2 also, right? So let's say we have this continuous function h. Let's say this is 2. And when x is less than 2, we have this function right here. And when x is equal to, we have this value right here. And when x is greater than 2, let's say we have this function right here. This function is continuous, right? So when x is equal to, right? When x is equal to, y value, function value has to be, they all have to be equal to each other, right? So when x is 2, when x is equal to, this y value must be equal to this y value, must be equal to this y value, right? They all have to be equal to each other. Does that make sense? When x is equal to. Okay, so let's write the equation. 2 times 2 squared minus 3. That is equal to 8 minus 3. That's 5, right? Here, if we substitute 2 for x here, that's going to be 4a minus 1, 4a minus 1 over 3, right? Here, if we substitute 2 for x here, we will have a b plus 2c, b plus 2c. Okay, so far so good. So this value is equal to this value, and it is also equal to this value right here, right? So let me rewrite the equation. 5 is equal to 4a minus 1 over 3 is equal to b plus 2c. Okay, if we solve this equation right here, that's going to be 15 is equal to 4a minus 1, 16 is equal to 4a, so a is equal to 4. So a is equal to 4, right? Okay, let's write this equation. 5 is equal to b plus 2c. Okay, so 5 is equal to b plus 2c. And we have another equation, right? When we look at this problem right here, there's information here. H of 4 is equal to 0, right? So when x is equal to 4, the y value is equal to 0. We have to substitute 4 here, right? Because 4 is greater than 2. Does that make sense? So when we substitute 4 here, y value, h value is equal to 0. So we'll have b plus 4 here, okay? 4. So 4c is equal to 0, right? So b is equal to then what? Negative 4c? So we can substitute negative 4c for this bit right here. So 5 is equal to negative 4c plus 2c. So negative 2c is equal to 5. So c is equal to negative 5 over 2. Is that right? Okay, so we found that c is equal to negative 5 over 2. What about b then? B is right here. So b is equal to negative 4 times negative 5 over 2. Negative times negative, positive. 2 times 1, 2 times 2. So that's going to be 10, right? So the answer, A is equal to 4, B is equal to 10, C is equal to negative 5 over 2. Question 78. Let f be a continuous function on the closed interval from 0 to 3. If f of 0 is equal to and f of 3 is equal to negative 3, then which of the following the intermediate value theorem guarantee? Okay, remember, the condition for intermediate value theorem to hold is that the given function must be continuous, right? Okay, so let's draw the function f. Here we have information f of 0 is equal to, and f of 3 is equal to negative 3, right? So if this is a 0, let's say here's a 2, so the point, the function value is here. When x is 3, y is negative 3. So the function value is here, right? Remember, the function is continuous. So I'm just going to draw one possible function, continuous function, like that, okay? All right, answer choice A. 1 of f of 1 and f of 2 must be equal to 0. So we know that there is a 0, at least one 0 between x is equal to 0 and 3. But does this have to be either f of 1 or f of 2? No, right? No, it doesn't have to be, okay? So A is not the answer. Okay, B. F of C is equal to 1. Y is equal to 1. For at least one C in the interval from 0 to 3. That is true, right? That is what intermediate value theorem is about. Here, y is 1, which is between 2 and negative 3, or negative 3 and 2, right? So if y is equal to 1, we must have x value between 0 and 3 that the function value is equal to 1. Does that make sense? Okay, so this is a C, this is f of C. Okay, so B is true. C, f of C is equal to 0, y is equal to 0 for at least one C in the interval. But look at this interval. Interval is negative 3 and 2, right? If this interval is from 0 to 3, then C is correct statement, right? Because this y is between negative 3 and 2, right? Does that make sense? Y is equal to 0. Here, y is equal to 0, right? So C is true when this interval is from 0 to 3. Okay? D, f prime is equal to 0. That's the slope of tangent line, right? Slope of tangent line has nothing to do with the intermediate phi theorem. So D is not true.